In this video, I will show you how to prove certain things in the coordinate plane that relate to quadrilaterals. For example, we're going to prove that this shape is a square, but we'll also prove things about the diagonals, like maybe we'll prove that the diagonals are congruent or the diagonals are perpendicular. So I'll show you how to prove things using coordinates. But first, we're told that this is a square. Now we have to put a check mark in every box that must be true. So we're going to have more than one check mark. So let's see. Has two pairs of parallel sides. Am I going to check that? Yeah, I'm going to check. This is a parallelogram. So opposite sides are parallel by definition. So we'll check that. Has exactly one pair of parallel sides? Obviously not. It's all both pairs. All four sides are congruent. Am I going to check that? Yeah, it's a square. That's the definition of a square. One pair of congruent sides? No, both pairs. Both pairs of opposite sides congruent? Yep, we'll check that. Two pairs of consecutive sides, but not all four. Nope, all four are congruent, so we're not going to check that. There are right angles at all four corners. Yep, that's because it's a rectangle. We check that. The diagonals are perpendicular. Am I going to check that? Yeah, because it's a rhombus, and that's one of the properties of a rhombus, is that diagonals are perpendicular. The diagonals are congruent. Are we going to check that? Yes, because of the properties of a rectangle. If you look at the chart we just did, rectangles have congruent diagonals, and a square is a rectangle. Am I going to check diagonals bisect each other? Yes, because that's the property on the chart we just did. That's the property of parallelogram at the top, and all of these are parallelograms, including square. So because this is a property of a parallelogram, we will check that the diagonals bisect each other. Okay, exercises like that with all the check marks, that's a really common thing to show up on a test. All right, can you see how memorizing the graphic organizer will help you fill out stuff like that? Anyway, aw shucks, use calculations and words. What did I tell you yesterday that we were going to have to do anytime you saw use calculations and words? That's right. This is looking for an introduction, a main body, and a conclusion. All right, and I'm going to color code those. I'll do my introductions in blue. Feel free to type some of this, like introduction and conclusion. If you write kind of big, you might want to type. Okay, so the definition of a square. The definition of a square is, what is the definition of a square? Right, four sides congruent and four right angles. All right, so we have our work kind of cut out for us. So here's my introduction. I will show that this is a square. By showing that it has four equal lengths and perpendicular sides. In parentheses, I'm going to put slopes, opposite, and reciprocal. All right, that's a little bit longer than our average introduction because it's really two problems in one. We're basically proving that this is a rhombus, and we're proving that it's a rectangle. So it's double the length of a normal introduction. The key words I'm looking for, if this were the test and I was grading it, equal lengths, because that's how we're going to show that it's a rhombus, and slopes opposite and reciprocal, because that specifically is how we're going to show that we have all these perpendicular sides, which are going to be right angles. If either of those are missing, then that's points that I have to take off. Okay, so that's the introduction. So now for the main body, I'm gonna do exactly what I said I was gonna do. Let's start with the equal lengths. So let's just go in order. Let's do AB. So the length of AB. So I'm just gonna use the Pythagorean theorem. Okay, so if I make a triangle over here like this, this is 3, and let's see, the height is 6. Please correct me on this because my eyesight's not the best. 3 and 6, is that what everybody sees? Okay, so that means this is going to be the square root of 3 squared plus 6 squared. Okay, so what's that going to be? The square root of what? Say that again. 45. Okay, so that's the square root of 45. Now let's do BC. All right, so BC is right here. And is this 6 again? All right, it's 6 and 3 again. So of course, that's going to give us the same answer, square root of 45. All right, now let's do CD. Okay, CD. Uh-oh. Yeah, I think I'll use big ink. Is that 6 and 3 again? Are all of these 6s and 3s? Radical 45. And that just leaves AD. I wonder what AD is going to be. All right, there's 3 and there's 6. Notice the kind of work that I'm showing. This is the absolute bare minimum of work that you're allowed to show. Do not skip the square root of 3 squared plus 6 squared part. Don't skip that and go straight to the radical 45. That will be points lost both on your homework and on the test. Okay, so that's half of the main body. We've done the part where we've shown that we have 4 equal lengths. Now we have to do the slopes, because that's how we're going to show perpendicular, that's how we're going to show right angles. Okay, so now it's time for slopes. Okay, so let's just find the slope of everything. So I'm going to find slope, slope AB, slope BC, slope, let's see, how much space do I have down here? Okay. Slope CD and slope AD. Okay, and I can use the triangles that I drew before to help me. The slope of AB, you see that it is, you see the rise and the run. You see the 6 and the 3. Is AB positive or negative though? AB is negative because it's downhill from left to right. Just don't forget that. So rise over run, that would be like 6 over 3. And maybe I'll just show this. So this would be negative 6 over 3, which simplifies down to what? Simplifies down to -2. All right, and then I glance at BC. Is BC positive or negative slope? Positive, because it's going uphill. Rise over run, that's 3/6. Which, of course, simplifies to 1/2. Okay, 1/2. Okay. And then CD is a negative slope. You see it's going downhill. There's your 6/3 again. Negative 6/3 again, which is -2 again. And AD, uphill, rise and run, that's 3/6. All right, positive 3/6. That's positive 1/2. Okay, so notice these connections, wonderful children. What do you notice when you look at the -2 and the 1/2? Those are opposite and reciprocal. Okay, and you see it everywhere you go. We did these in order, so it's easy to see consecutive sides. All right. So if we look at the next pair, 1/2 and -2, those are opposite and reciprocal. -2 and 1/2. And then really to wrap it around, if you look at the AB and the AD, those are actually right next to each other as well. And again, they are opposite and reciprocal. So every pair of consecutive sides are opposite and reciprocal. That means every pair of sides is perpendicular. Okay? And that's what we're going to say now it's time for the conclusion. Okay, so don't forget, we had to prove it was a rhombus and a rectangle, 4 equal sides and 4 right angles. So since, hold on, I'm supposed to do this in purple. Since it has 4 equal lengths, okay, messed it up. All the sides are congruent. Since each pair of consecutive sides have opposite and reciprocal slopes, there are 4 right angles. Therefore, this is a square. All right, that's about as long as a problem can possibly be, because it's really double the length. So my introduction is double long, my work is double long, and my conclusion is double long. So this is as bad as it gets. All of the other ones are going to be easier than this. All right, let's switch gears a little bit. So use calculations and words to demonstrate one property that must be true about the diagonals of the quadrilateral. Okay, so we have a bunch of properties that we could prove. The diagonals are perpendicular, the diagonals are congruent, the diagonals bisect each other. Okay? If I wanted to prove that the diagonals were perpendicular, what would I have to do? How would I go about doing that? Slope. Okay? And specifically, what about the slope? Correct. All right? So if I wanted to show the diagonals were perpendicular, I'd have to show that slopes, opposite, and reciprocal. Okay, if I wanted to prove that the diagonals were congruent, what does that mean? What do I have to prove? What do I have to show? What's the key word? It's going to be length. This one's going to be length. We'd have to show that they have the same length. Okay, now, if I wanted to show that the diagonals bisect each other, what would I have to show? That's the midpoint, okay? I'd have to show they have the same midpoint. Nadia, you choose which one we're going to do. Cole, head up, eyes open, get to work. Bisect each other. Okay, we could have picked any of these three. We're going to go ahead and do bisect each other. Actually, at the end of the video, I'm going to go ahead and show the other two as well. So tune in at the end to see how to prove that the diagonals are perpendicular and prove that the diagonals are congruent to each other. Okay, we need to do an introduction, main body, and conclusion. So, okay, I will show that the diagonals bisect each other by showing that they have the same midpoint. All right. You're not going to do this, Cole? Are you, though? All right. I'll come check at the end of class. So that's my introduction. Let's show that they have the same midpoint. So now in the main body, we're going to do what we actually said we were going to do. Okay? So previous experience warns me that sometimes students don't actually know what a diagonal is. Name a diagonal. AC is a diagonal. All right, there's only one other diagonal. What is it? Right, DB is a diagonal. So diagonal doesn't mean it's a slanty looking side. It's diagonals connect the opposite angles. So those are the two diagonals. I need to prove that they have the same midpoint. What is the midpoint formula? What do I do? Correct. All right. You can think of midpoint as the average of the x's and the average of the y's. Let's see. Let's do AC first. So the midpoint of AC is going to be the following. Okay. So this is the point 2, hold on, I need to write a little bit bigger. Point A is 2, 4, and point C is -1, -5. Okay, so the x's are 2 and -1. So that's why I'm going to go 2 plus negative 1 divided by 2. It's the average of the x's. Now I'm going to do the average of the y's. So that's 4 and negative 5. So 4 plus negative 5 divided by 2. All right, so that's going to give me 1/2, comma, negative 1/2. All right, so that is the midpoint of AC. So the other diagonal is DB. Okay, so now let's find the midpoint of DB. So point D is negative 4, comma 1. And point B is 5, comma negative 2. Okay, so the x's are negative 4 and 5. So I'm going to go negative 4 plus 5 over 2. The y's are 1 and negative 2. So I'm going to go 1 plus negative 2 divided by 2. And that is going to give me 1/2 and negative 1/2. All right, notice that these midpoints are the same. So, conclusion. Since the midpoints are the same, the diagonals bisect each other. Okay, so we just proved that the diagonals bisect each other. Now let's prove that the diagonals are congruent. So my introduction is going to be, I will show that the diagonals have the same length. Boom, that's my introduction. Now here comes the main body where I'm going to do exactly what I just said I was going to do. These are the diagonals. Let's start with the diagonal DB. So let's find that length. Let's find the length of segment DB. All right, let's use the Pythagorean theorem to do this because that's my favorite. Make a right triangle out of it is the easiest way. The vertical side is length 3. The horizontal side, let's see, that's 3, 6, 9. Okay, let me just double check. 4. Okay, that's right. So 3 and 9. That means that the hypotenuse will be the square root of 3 squared plus 9 squared. Let me just clean this up before I go back to this. So this is going to equal the square root of 3 squared plus 9 squared. All right, so that's going to be 9. This will be 9, and this will be 81. So that's 90. So this is going to be the square root of 90. All right, because 9 plus 81. Okay, now let's find the length of AC. All right, so the length of segment AC is going to be the square root of... Okay, again, let us do the Pythagorean theorem. So that's going to be like this and like this. Interesting. This is 3, and this side is 9. So again, it's going to be the square root of 3 squared plus 9 squared. So of course that's going to give me the same length, square root of 90. Time for the conclusion. Since the diagonals have the same length, they are congruent. So that is how you prove that the diagonals are congruent. Next, we will prove that the diagonals bisect each other. No, we already did that one. Finally, we will prove that the diagonals are perpendicular. So finally, we will prove that the diagonals are perpendicular. So let's start off with our introduction. So in order to prove that the diagonals are perpendicular, I have to show that the slopes of the diagonals are opposite and reciprocal. So bam, there's my introductory statement. So now for the main body, I need to do what I just said I was going to do. So let's start with the diagonal DB. So that means we're going to have to find the slope of segment DB. Okay, so let's investigate the slope of segment DB. For that, it will be helpful to really emphasize the rise and the run. You know what, maybe I'll just use purple, actually. All right, so the rise and the run of this thing are like this. Okay, that's the rise, and this is the run. So you can probably see that this is 3, a length of 3, and this is a length of 9. So I've got the 3 and the 9. So rise over run, that's 3 over 9. But be careful, this is downhill from left to right. That is a negative slope. So the slope will be negative 3 over 9. In fact, some students will say, well, we went down and right. That's negative 3 and positive 9. Negative 3 over positive 9, that's going to be the slope. Okay, whichever way you want to look at it. Let me clean this up a little bit. So, negative 3 over 9, which of course reduces to negative 1/3. Now let's look at the slope of the other diagonal, shown here in green. That's AC. So let's analyze the slope of segment AC. And let's see what's going on. Okay, so let's use that same technique. Let's see, wait, I wanted to do purple though. So let's consider the rise and the run of this thing. So here's the rise, and here is the run. So perhaps you can see that this is up 9 and over 3. This is uphill, so it is positive. But the rise is 9 and the run is 3. Rise over run is 9 over 3. Okay, so keep that in your mind. 9 over 3. Positive 9 over 3. Now, of course, 9 over 3 reduces down to simply 3. Now, notice that these are opposite in sign, because one is negative, one is positive, and they are reciprocal, because I have 1 over 3 and 3 over 1. Those are reciprocal. So these are in fact opposite and reciprocal, just like I said. So I'm ready for the conclusion. Since the slopes are opposite and reciprocal, the diagonals are perpendicular. So that's how you prove that the diagonals are perpendicular with your introduction, main body, and conclusion.